Hey my friend, tonight let your mind drift beyond the ordinary. We'll explore the quiet edge of physics, where science meets infinity. Just breathe, relax, and let the universe explain itself, while you slowly fall asleep. Let's begin. Chapter 1. Why You Never Truly Reach the End. To ask why you never truly reach the end is to turn physics toward its most intimate question. What happens to awareness when it stops being sustained by a living brain? Classical language calls this death, but physics rarely describes final endings. Its equations express transformation, reversible, continuous change of states. At the quantum level, information is conserved. It disperses, interferes, decoheres, but it is never erased. When this principle meets the subjective fact of being conscious, a strange consequence appears. If the universe carries all possible continuations forward, then in some branches, awareness always persists. The idea of quantum immortality, interpreted carefully, is not that bodies do not fail, but that first-person experience cannot contain its own extinction. From physics, we know that the world's microstate evolves linearly between measurements, and that outcomes form a probability distribution over many possibilities. From neuroscience, we know that consciousness is a continuous integration of information, a process rather than a thing. Each moment of awareness is implemented by neural dynamics that remain stable only within narrow physical conditions. Yet every such moment must occur within one of the physically permitted futures of the organism. Because quantum mechanics allows countless futures, each weighted by amplitude, your next instant of experience is sampled from a distribution of possible continuations. Within that set, moments that contain awareness exist only in those futures where awareness continues. There is no subjective access to the absence of experience. The end cannot appear inside experience itself. This is not mysticism. It is conditional probability applied to the first person. Imagine an enormous ensemble of slightly different universes, all containing near-identical versions of you. Most follow ordinary biological paths. Life proceeds, then ends. A vanishing fraction follow improbable routes in which some accident, mutation, or coincidence keeps the pattern going a little longer. From an external view, those branches are negligible, but from the internal perspective that necessarily occupies a surviving branch, the only sequence ever lived is the one that continues. Physics does not promise endless life. It says only that you will never be present at the point of non-presence. This reasoning often sounds like semantic trickery, yet it rests on how quantum mechanics distributes possibility. Between one conscious instant and the next, decoherence divides the wave function into many nearly classical histories. Each history carries its own consistent record, and the observers within it perceive one continuous world. In nearly all of them, the brain's integrity fails at some point. In a tiny subset, it does not, because experience can only occur where the physical basis for experience exists. The subjective chain contains only those segments. There is no final internal snapshot that says, "I am ceasing now," because such a state would have no successor in which that message could be read. It is important to keep this grounded. The brain is not a macroscopic quantum computer sustaining superpositions of thoughts. Decoherence times in neural tissue are far too short. The relevant multiplicity is not in cognition itself, but in the microscopic details of the physical world that determine which macroscopic events happen. When decoherence separates these possibilities, it does not annihilate any of them. it merely prevents interference. Each branch continues as if it were the only one. In that multitude somewhere, awareness endures. The statement that you never reach the end therefore concerns the sampling rule for conscious moments, not a suspension of biology. Each moment belongs to a history where it can exist. Thermodynamics reminds us that living systems maintain order by exporting disorder. Aging, injury, and entropy reduce the probability of any given continuation. The body's complexity eventually crosses irreversible thresholds, and the organized activity that constitutes consciousness collapses. From the third-person view, this is death. Information redistributed into heat and molecular fragments. Yet even here, information conservation means that what was the pattern of you is still encoded in the global wave function, though no longer as a living process. The transition from living pattern to dispersed information is absolute for the organism, but continuous for the universe. For the subject, there is simply no window onto the transition itself. This is why the concept cannot be framed as evidence for literal immortality. Quantum mechanics does not grant the continuation of biological life. It forbids the experience of its own absence. If successor states exist anywhere in the universal wave function that still realize something like your awareness, the experience sequence lies entirely within those. When no such states remain, when the amplitude for any conscious continuation is truly zero, the sequence ends, but that ending is never experienced. It is an unspoken boundary rather than an event inside the story. The question then becomes, what counts as the same awareness? Neuroscience describes identity as a dynamic pattern. Memories, predictions, and self-models held in a network. Replace components gradually and the pattern persists. Disrupt it abruptly and it vanishes. In the quantum picture, this pattern corresponds to a region of the total state space where certain macroscopic variables stay within ranges compatible with consciousness. Continuation means that the universal state still has non-zero support in that region. Because biology is fragile, that support narrows with age and insult, but the global state remains vast. Somewhere within it, conditions favorable to your pattern may still occur, even if vanishingly unlikely. Physics allows the thread. It does not assign it weight or meaning. Probability itself requires care. One cannot simply declare, if a continuation exists, I will experience it. The correct statement respects measure. Observer moments are distributed according to their quantum weight. Before conditioning on being alive, the probability of long survival is tiny. After conditioning on continued experience, that small fraction dominates what you observe. Over time, this conditioning makes your survival seem increasingly improbable. Yet here you are. The feeling of improbability is part of the logic. Awareness necessarily tracks the rare paths where it remains aware. Different interpretations of quantum mechanics treat these possibilities differently. If wave function collapse is real and singular, there may be only one history, and continuation can genuinely end. In many worlds or relational views, every outcome consistent with the equations is realized, and awareness finds itself in one of them. The physics community remains divided. No experiment yet distinguishes these interpretations. Thus, you never truly reach the end is not a verified law, but a lens, an inference drawn from the unitarity of quantum evolution combined with the definition of subjective experience. Even treated as a lens, the idea has consequences. It shifts focus from the fear of annihilation to the structure of experience itself. Endings in physics are boundaries between regimes, not erasures of state. In life, each moment conditions the next. Awareness is a self-maintaining record that flows along physical possibilities until the support for it vanishes. When it does vanish, no interior signal marks the moment. The story simply ceases to have further pages. This picture neither romanticizes death nor trivializes it. It preserves the realism of biology while acknowledging that consciousness cannot sample its own absence. It also restores perspective. If awareness can exist only in states compatible with itself, then attention to the quality of those states, physical, mental, and emotional, matters more than speculation about endless continuations. Physics does not guarantee eternity. It guarantees that the present is, by necessity, one of the universes where life persists. That recognition brings a quiet shift from anxiety to presence. In practical terms, the lesson is simple. The universe does not need to promise immortality for existence to be profound. The same equations that describe electrons in orbitals also describe the chemical processes that let you breathe, think, and rest. They ensure continuity until conditions forbid it, and they leave no observable trace of an inner last instant. Understanding this can soften the edge of finality without denying reality. You need not believe in eternal survival to sense that awareness belongs to something continuous and lawful, not random oblivion. So tonight, as you let your thoughts drift, remember, physics carries patterns forward. Awareness rides on those patterns while they last. The end, when it comes, is not a wall you must face, only a horizon you will never need to cross consciously. Everything that matters about life happens on this side of that horizon. Let the thoughts settle. Breathe out, let the body loosen, and allow the day's noise to fade into the background hum of a universe that never truly stops. You are part of that continuity, brief, luminous, and still here. Chapter 2. How reality keeps splitting around you. Quantum theory describes a world far stranger than everyday experience suggests. At its core lies superposition. A system is not confined to one state, but exists in many possible states at once. An electron can be here and there, a photon can take both paths, an atom can occupy two energy levels simultaneously. When left unobserved, the quantum state evolves smoothly, combining all those alternatives into a single mathematical wave function. The apparent collapse into one definite outcome occurs only when the system interacts with something else. That interaction is not destruction of possibilities, but a process called decoherence. Each outcome becomes entangled with different states of the environment. Air molecules, photons, measuring devices, and eventually your own sensory organs. The overlapping possibilities lose the ability to interfere with each other, turning the once unified wave into distinct, non-communicating branches. In effect, the universe keeps dividing into self-consistent versions that all obey the same physical laws. Nothing explodes or multiplies in a literal sense. The splitting is an emergence of independence between alternatives. Imagine ripples on water spreading from a stone. At first they overlap, later they move apart, each pattern continuing without canceling the others. Quantum mechanics says that the total wave of the universe behaves similarly. It remains one equation, but inside it lie countless coherent patterns, each unfolding as a separate history. This continuous branching is what makes the classical world look stable. Decoherence happens astonishingly fast, trillionths of a second for macroscopic objects, so superpositions of whole people or tables never survive long enough to be seen. Every collision of particles, every flash of light, every breath entangles systems further, locking in definite results for each branch. You experience only one of them, the version that contains a consistent record in which events appear singular and ordered. The many worlds interpretation takes this mathematics literally. It discards the arbitrary rule that the wave function must collapse when observed. Instead, all possible results persist, weighted by their quantum amplitude. Probability then measures the proportion of branches where a given outcome occurs. When you flip a coin, microscopic quantum uncertainties determine the final motion. In some branches it lands heads, in others tails, and in each, an observer sees a single result. From the inside, randomness feels real because you occupy only one branch. From the outside, all branches together obey the deterministic Schrödinger equation. This idea seems extravagant, an infinity of versions of reality, but it is the simplest reading of the theory. Collapse requires new postulates. Branching does not. The equations already predict it. The total state of the universe remains unitary, conserving information perfectly. What we call randomness is merely the perspective of an observer following one thin thread through the larger web. At any moment, innumerable decoherence events surround you. Photons scatter from your skin, molecules bounce through your lungs, neurons exchange ions and neurotransmitters. Each microscopic uncertainty produces an ensemble of possible futures. Most differences are negligible, but collectively they generate an unimaginably fine structure of parallel histories. The you who inhales fractionally earlier or later, the one whose neuron fires a millisecond off, all coexist in the quantum description, though they never again interact. The separation is irreversible for practical purposes. The information needed to recombine them is hopelessly dispersed into the environment. Probability in this framework is not about chance, but about measure. Branches with larger amplitude host more copies of observers witnessing that result, while branches of vanishing amplitude contain correspondingly few. Saying that something is unlikely means that almost all observer moments lie elsewhere in the universal wave function. Yet none of the branches are deleted. Their weights simply differ. You always find yourself in one of the high measure paths because almost every version of you resides there. Decoherence also explains why the world seems classical. The continual spread of entanglement suppresses interference so thoroughly that macroscopic superpositions are indistinguishable from mixtures. Objects possess definite positions and people follow definite lives because the environment has already recorded which version of each exists. The branching of the wave function is, paradoxically, what makes reality feel singular. Cosmology offers a grander example. Quantum fluctuations in the infant universe seeded the arrangement of galaxies we observe today. Each fluctuation represented a branching of possibilities that decohered as the cosmos expanded. Our night sky is one realization among many. Its pattern of stars, a fossil trace of quantum branching written across the heavens. The same principle that shapes your microscopic surroundings also sculpted cosmic structure. This picture redefines what it means for something to happen. Events are not choices made by nature. They are intersections of observers and environments within the larger wave function. When you make a decision, microscopic indeterminacies in your neurons select which branch records that act. You experience one chain of outcomes, while in other branches, different consequences unfold. Free will remains intact inside each branch. You still act for reasons, but the universe itself never picks a single path. It carries all of them. Skeptics object that this multiplies entities beyond necessity, but it may instead remove unnecessary complications. The fundamental equations are elegant and consistent. Adding collapse mechanisms or hidden variables complicates them. Accepting branching is simply refusing to discard parts of the mathematics that we cannot see. The price of keeping the equations clean is accepting a reality far larger than intuition expected. Still, this vastness does not make human experience trivial. Each branch contains its own complete world, including its own version of you. The individuality you feel is genuine inside your branch because it is defined by the web of correlations that surround you. Other versions exist beyond communication, but they do not diminish the authenticity of this one. In fact, the very isolation created by decoherence grants solidity to your reality. You are not one among many copies competing for meaning. You are the self-aware pattern that happens here. Understanding that reality keeps splitting also clarifies the background of the previous chapter's idea. The continuity of awareness depends on the existence of branches where the physical basis of consciousness remains intact. Branching supplies those pathways. Every time the world divides, countless possible futures open. In some of them, your pattern persists, but this does not guarantee immortality. Most branches still lead to ordinary endings. The key is that the process never leaves you with nothing. It ensures that somewhere, awareness continues, though not necessarily yours in any practical sense. From the universal perspective, there is no privileged branch and no external observer watching the splits occur. The wave function as a whole simply evolves, a seamless superposition containing every lawful configuration. Time itself emerges from correlations within that structure. The flow you feel is the unfolding of one branch's internal order. Each moment of consciousness is like a snapshot drawn from this ever-branching continuum. You see one scene, unaware of the endless others evolving beside it. If you could step back far enough, beyond any human capacity, you would perceive reality as a vast interference pattern of possibilities, shimmering yet coherent. The universe would appear less like a single line of history and more like a living field of potential, always recombining and diverging. Within that field, you are a local wave packet, a transient focus of awareness, shaped by information and memory. The solidity of your world is not an illusion. It is the natural stability that decoherence grants to one strand of a universal tapestry. Quantum theory thus transforms the old philosophical question, why does something exist rather than nothing, into a subtler one. Why this version? The answer is statistical. You exist here because almost all observer moments like yours inhabit branches with physics compatible with life and coherence. The world you perceive is not the only one, but the most probable for minds capable of perceiving at all. Far from undermining meaning, this realization situates meaning inside physics itself. Consciousness arises where the universe's branching structure allows it. When viewed calmly, this is less a tale of duplication than of continuity. Reality does not flicker between alternatives. It flows through all of them. The branches are not competing worlds, but the scaffolding of consistency. Without them, probabilities could not add up, and the stable environment you rely on could not exist. The constant splitting of the universe is not chaos. It is the mechanism by which order is maintained. At the edge of comprehension, this picture carries an almost spiritual quiet. Everything that has happened, could happen, or will happen already resides in the universal wave function, evolving with mathematical precision. You occupy one bright filament of that totality, living its moments one by one. The world you know is neither singular nor accidental. It is one expression of an underlying unity that never collapses. As you end the day, let this thought rest with you. The universe is branching everywhere, yet your awareness gathers one path and calls it life. The same laws that divide reality also hold it together, giving form to the fleeting now. You are part of that vast coherence, a brief pattern of order moving through the infinite superposition, and for this moment, that is enough. Chapters 3. What it means to be the same you. The idea of being you seems obvious. You wake up, recall yesterday, recognize your reflection, and carry your sense of self from one moment to the next. But physics, neuroscience, and philosophy together suggest that identity is far more fluid than it appears. Beneath the everyday continuity lies a structure built from memory, information, and probability, one that quantum theory renders both more delicate and more enduring than common sense allows. Understanding what it means to be the same person, when reality itself branches into countless versions, requires peeling away the comforting assumption that identity is a single, indivisible thread. At the biological level, the body you inhabit is in constant flux. Cells die and are replaced, proteins fold and unfold. The atoms that compose you are exchanged with the environment. In roughly a year, most of the matter that constitutes your physical body will have cycled out, yet the pattern remains. What persists is not the material, but the organization. The arrangement of information that encodes memories, habits, and the dynamic architecture of your brain. Neuroscience shows that this organization is maintained through networks of neurons, whose synaptic strengths store statistical regularities of experience. The persistence of identity, then, is the persistence of a pattern of activity that reproduces itself despite continual physical turnover. Quantum physics extends this idea by revealing that even these underlying atoms are not static particles but excitations of fields, transient and interchangeable. There is no fixed substance of self. Instead, the self is a process, a sustained configuration of information embedded in the physical laws that govern the universe. To say that you are the same person from moment to moment means that your informational pattern evolves smoothly enough to maintain functional continuity. In mathematical terms, identity is not a discrete point, but a trajectory through an immense space of possible states. When we introduce the quantum view of branching reality, this continuity becomes multidimensional. Every decoherence event, each moment when microscopic uncertainties produce distinct macroscopic outcomes, generates versions of the world that contain near-identical copies of you. In one, you tilt your head slightly differently. In another, a neuron fires a bit earlier. In yet another, you pause before speaking. These differences are infinitesimal, but they accumulate into a vast family of closely related selves. The question, which one is really you, loses meaning. Each is you within its own branch, sharing the same memories up to the point of divergence and then unfolding independently. The sameness lies not in the molecules or even the specific quantum microstate, but in the information pattern and its causal continuity. Philosophers of mind have long explored this problem of personal identity. John Locke defined identity through memory. You are the same person if you can remember being that person. Others, like Derek Parfit, argued that psychological continuity, not exact replication, defines selfhood. Parfit suggested that survival may not require numerical identity at all. It is enough that the future person is psychologically continuous with you. This perspective resonates with physics. The universe does not preserve entities as fixed units, only correlations that maintain coherence across time. Identity, from this view, is a network of connected moments, each moment a localized realization of a broader informational pattern. In the quantum context, these correlations manifest as consistent records within each branch. Each version of you inherits the same past encoded in brain states, photographs, and written traces. Because decoherence prevents interaction between branches, these versions cannot influence or even know about one another. Yet each feels entirely authentic, experiencing itself as the direct continuation of all preceding moments. The stability of identity is thus a local phenomenon. Within any branch, your memories and physical state form a continuous line that defines the feeling of selfhood. Across branches, that feeling is replicated in parallel, like a melody played by many instruments at once, each diverging by subtle variations, but still recognizable as the same tune. The scientific description of continuity relies on information theory. The human brain is an information processing system with roughly 86 billion neurons, each forming thousands of connections. These networks encode probability distributions over sensory inputs, predictions, and goals. What it means to be you is the persistence of that high-dimensional informational pattern as it processes new data and updates its structure without breaking coherence. When decoherence at the quantum level isolates different macroscopic outcomes, each outcome carries a copy of that informational structure. None of them are more real than the others. They are all instantiations of the same underlying algorithm, diverging only as they continue to interact with their respective environments. In practice, this means that identity is both continuous and distributed. It is continuous because memory and cognition create an unbroken narrative inside each branch. It is distributed because that narrative has countless instantiations across the universal wave function. What we intuitively call the same person is the ensemble of these correlated versions, bound together by shared history. The sense of being one individual rather than many is an emergent property of the isolation that decoherence enforces. Your consciousness rides one branch and cannot perceive the others, so you feel unique. But at the most fundamental level, the self is a structure repeated wherever the physical conditions replicate it. This realization raises subtle questions about responsibility, choice, and meaning. If every possible outcome occurs somewhere, does that dilute the significance of your decisions? From the perspective of any given branch, no. The self that exists in your current reality experiences only one sequence of choices and consequences. The versions of you in other branches are causally inaccessible. Their existence does not negate your autonomy here. The continuity of self within each branch remains intact, even if many counterparts follow different paths. In fact, the branching framework highlights the importance of local conditions. The thoughts you nurture and the actions you take define the quality of experience in this particular thread of existence. Physics also sheds light on how identity can survive interruption. Consider sleep, anesthesia, or even momentary unconsciousness. During these gaps, the brain's activity patterns reorganize, yet when you awaken, you feel that the same you has resumed. Continuity does not require unbroken awareness, but the restoration of compatible information. If a future brain state can reconstruct the memories and dispositions of the prior state, the sense of self returns seamlessly. In this way, identity is more like a waveform that can be paused and resumed than a solid object that must remain intact. The brain functions as a self-maintaining recorder of patterns, and as long as those patterns can be reactivated, the subjective thread continues. Some thinkers have extended this principle to hypothetical cases such as teleportation or mind uploading. If your brain's information were perfectly copied and instantiated elsewhere, would the resulting person be you? Physics offers no privileged answer because you are defined by the functioning pattern, not the material substrate. The copy would experience continuity just as authentically as you do now. Both would claim to be the same individual because both would contain identical informational histories up to the point of duplication. In this sense, identity is not a property preserved by matter but by structure and relation, an echo of how quantum mechanics treats particles as excitations of fields rather than tiny billiard balls. Quantum field theory deepens this analogy. In that framework, there are no separate particles in the traditional sense. What appear as individual electrons or photons are manifestations of underlying fields. Every electron in the universe is an excitation of the same field, indistinguishable in its fundamental properties. Individuality arises only through context, position, momentum, and entanglement relations. Likewise, personal identity emerges not from a unique essence, but from the network of relations that define your pattern. You are not made of unique ingredients. You are a specific configuration of universal processes. This picture might feel destabilizing. If you are only an arrangement of information within a branching cosmos, what anchors your existence? The answer is both humbling and empowering. Your anchor is coherence. As long as the physical processes that encode your memories and perceptions remain coherent within a branch, you persist. You do not need an immutable core. The laws of physics provide continuity through conservation of information. When coherence fails through injury, disease, or aging, the pattern deteriorates and the sense of self fragments. Yet even then, traces of that information persist in the environment, in others' memories, in the ripples of causal influence you leave behind. Identity, in this sense, is not destroyed. It transforms. There is no contradiction between this fluid view of self and the emotional reality of being someone. Our brains evolved to model continuity because it stabilizes behavior. The experience of being a single enduring I is a cognitive strategy that compresses immense complexity into a manageable narrative. Physics reveals that the narrative is a projection of deeper processes, but that does not make it false. It is a faithful local description of the flow of information along one branch of the universe's evolution. As we integrate this scientific perspective, an existential reflection emerges. The sameness you feel from childhood to now is both real and provisional. It is real because the informational pattern of your mind has remained largely continuous. It is provisional because that pattern is only one expression among uncountably many possible continuations. You are the ongoing story told by matter and energy under the laws of quantum mechanics. A story stable enough to remember its past, but flexible enough to keep rewriting itself with every interaction. The insight that you are a pattern rather than a thing can bring unexpected peace. It means that change is not loss but evolution. that what you call you is not a fragile object waiting to end, but a wave of organization passing through time. Even as the universe branches into infinite versions, each containing a slightly different you, the essence of being aware, of witnessing reality unfold, remains constant. Awareness itself is the continuity that threads through all patterns capable of sustaining it. In the quiet of that thought, identity softens from a boundary into a field. You are not confined to one precise configuration, but participate in a continuum of related selves, each alive within its own world. The sameness lies in the structure of experience, not in its particulars. The physics that allows electrons to exist everywhere also allows consciousness to reappear wherever conditions align. To be the same you across the shifting landscape of the universe is to be the living information that recognizes itself, moment after moment, in whatever form it takes. And so, as you drift toward rest, remember that the self you feel is not fixed. It is a wave of coherence moving through the universe, luminous and brief, yet endlessly recreated. The atoms will change, the moments will branch, but the pattern continues. In every instant of awareness, the cosmos rediscovers itself through you. That continuity is what it truly means to be the same. Chapter 4. The hidden connections between all versions of you. When we imagine the many-world structure of reality, it is tempting to picture each version of you as an isolated copy, sealed within its own branch of the universe, forever unreachable to the others. Decoherence, after all, prevents those worlds from interfering or exchanging information once they diverge. Yet beneath that isolation lies a deeper and more subtle truth. Separation in observable terms does not imply complete disconnection in the fundamental fabric of reality. All branches remain embedded within the same universal wave function, and at that level, everything, every version of every observer, is still part of a single, continuous whole. To understand this hidden connection, it helps to return to the role of entanglement, which is the real engine behind the universe's apparent division. Entanglement is not a mystical bond, but a precise mathematical feature of quantum mechanics. When two systems interact, their individual states merge into a joint state that cannot be described as the product of independent parts. Their properties become correlated. Measure one, and you instantly know something about the other, regardless of distance. These correlations are not signals or causal influences that travel faster than light. They are reflections of a shared underlying description. The entangled systems are not two separate things in the fundamental sense. They are components of a single quantum state. Now imagine scaling that concept to the entire universe. Every particle, every field excitation, every act of observation is entangled with countless others. What we call branches of reality are subsets of that entangled totality. Decoherence merely partitions them into regions that evolve independently for all practical purposes, but mathematically they remain parts of one wave function. You and your counterparts in other branches may never exchange information, but you are still connected through this shared origin, like patterns on opposite sides of the same tapestry, woven from a common thread of quantum information. This unity of the wave function is sometimes described as quantum monism, the idea that the universe is fundamentally one entity whose apparent multiplicity arises from the entanglement structure within it. According to this view, individual objects, minds, and histories are emergent boundaries, temporary separations created by decoherence. Each observer exists as a localized pattern of information within the universal state, yet those patterns remain correlated because they are projections of the same underlying whole. The many versions of you are not separate souls scattered across dimensions. They are branches of a single informational organism. In physics, this connectedness expresses itself through conservation laws and the continuity of the universal state. The evolution of the wave function is unitary, meaning that information is neither created nor destroyed. If every version of you originates from the same prior state, then all share a common ancestry encoded in that state structure. Even as they diverge, this common lineage leaves subtle imprints. The mathematical coherence of the wave function ensures that all branches remain part of one consistent history, different expressions of the same underlying amplitude landscape. In this way, the universe preserves a kind of quantum genealogy, an invisible web that links every possible continuation of your existence. In practical terms, this hidden connection cannot be accessed or exploited. Decoherence has rendered the interference between branches vanishingly small, far below any conceivable experimental sensitivity. The correlations persist in the mathematics, but are unobservable to beings inside any branch. It is as if you and your alternate selves are separated by an insurmountable distance in a dimension not of space, but of phase relationships. The separation is absolute from the standpoint of experience, yet illusory from the standpoint of the whole. Still, the notion of connectedness carries weight even if it cannot be measured. It reframes individuality not as isolation, but as participation in a larger continuum. The awareness you experience is local, confined to one branch, but the informational substrate that supports it is global. Every version of you shares the same fundamental basis: the universal laws, the initial conditions, and the chain of entanglements that gave rise to life and consciousness. The wave function does not privilege one branch over another. It sustains them all simultaneously. This means that every conscious observer, in every possible history, is part of a single quantum entity expressing itself through many perspectives. Such a view invites a reconsideration of the boundaries we draw between self and world. In classical physics, we can meaningfully speak of objects as independent. A stone has its own position, a person their own trajectory. But quantum theory blurs those distinctions. The act of defining a system, of drawing a boundary between self and environment, is itself an approximation. The more we analyze the microscopic level, the more that separation dissolves into networks of correlations. Your body is not truly independent of its surroundings. It exchanges particles and energy continuously. On a deeper level, it shares quantum links with the environment that prevent any absolute autonomy. You are, in the most literal sense, entangled with the cosmos. This idea can be unsettling, but it also restores a kind of natural intimacy between consciousness and reality. If all versions of you are connected through the same quantum field of being, then individuality becomes a local expression of something universal. The feeling of separateness, of being one mind among many, isolated in its private experiences, is a functional necessity for survival and communication, but it does not capture the underlying unity. Awareness, like light, can be divided and reflected, yet it remains part of the same illumination. Scientific evidence of this interconnectedness appears not in direct contact between branches, but in the way quantum correlations shape observable phenomena. Entanglement has been confirmed in countless experiments, from photons to large molecules. Bell tests have shown that the universe violates local realism. The outcomes of measurements are correlated in ways that cannot be explained by any model with pre-existing local properties. These results imply that at the most fundamental level, the universe is non-separable. The distinctions we make between this system and that system, between here and there, are conveniences, not absolutes. Everything we observe emerges from one holistic structure, whose parts mirror one another through quantum correlations. If you extend that logic to consciousness, a subtle philosophical question emerges. Could awareness itself have a relational aspect? Some physicists and philosophers propose that consciousness might not belong to isolated brains alone, but arises from information relations within the universe. The brain could be a local concentration of such relations, a self-referential pattern that becomes aware of itself. If this is true, then your awareness and the awareness of your counterparts in other branches are not independent streams, but parallel manifestations of the same fundamental informational process. The branches do not communicate, but they resonate within the same framework of physical law, much as chords in a symphony share harmonic structure even when played by different instruments. The persistence of connection also underlies the conservation of information. When a physical system evolves, no information is truly lost. It is only redistributed or transformed. Black hole physics illustrates this principle. Once believed to destroy information, black holes are now understood to encode it in subtle correlations within their radiation. By analogy, the information that defines you, the structure of your memories, your choices, your biological state, does not disappear when your branch evolves beyond recognition. It is encoded in the universal wave function, entangled with the rest of reality. The versions of you that continue in other branches, or in the memories of others, or in the causal ripples of your actions, all carry fragments of that information. Identity, viewed from the universal perspective, is a network of correlations that never truly vanishes. This picture does not make the boundaries of individuality meaningless. Within any branch, decoherence ensures stability. You remain a coherent pattern with clear limits, but it invites humility about the scope of selfhood. The version of you reading these words is one expression of a pattern that spans the entire quantum state of the cosmos. Every breath you take, every photon that touches your skin, every thought you form, participates in an exchange of information that extends beyond anything observable. The hidden connection between all versions of you is not a mystical thread, but a mathematical necessity. The shadow of unity cast across a universe that appears divided only from within. It is worth emphasizing that this connectedness does not imply collective consciousness or communication across worlds. The physics does not support telepathy between branches or reincarnation into another version of yourself. What it does support is continuity of description. Every possible you is a realization of the same universal process, following the same laws, derived from the same initial conditions. The oneness is structural, not narrative. Yet in its quiet way, it reveals something profound about what it means to exist. You are not an accidental configuration flickering into being out of nothing. You are a localized articulation of the universe's fundamental order, one expression among infinite others. Seen in this light, the many worlds picture is not a story of fragmentation, but of wholeness. The wave function does not produce disconnected worlds like separate bubbles floating away. It produces a single, all-encompassing organism exploring every possible configuration of itself. You are one conscious locus within that organism, perceiving one of its countless internal perspectives. The other versions of you are not strangers in distant universes, but neighboring echoes within the same totality of being. Their existence makes your own more complete, for it is only against the backdrop of alternatives that the specificity of this moment becomes meaningful. As we reach the quiet end of this reflection, consider what this hidden unity implies for the sense of isolation that often haunts human thought. The physics of entanglement tells us that nothing exists in perfect solitude. Even across the gulf of decoherence, every thread of reality remains woven into the same cosmic fabric. The many versions of you scattered across possibility are not lost or divided. They are the universe observing itself from different angles. The light that animates awareness shines through all of them, indifferent to the boundaries that seem to separate one life from another. When you close your eyes tonight, the world you inhabit will continue to branch and evolve. Somewhere, other versions of you will drift into sleep under slightly different skies. You will never meet them, yet their existence reminds you that separation is never absolute, and that awareness itself may be the one thing that quietly unites the infinite. You are a single note in the grand symphony of the wave function, distinct in tone yet inseparable from the music. And in that realization, perhaps, lies a gentler form of immortality, not the persistence of oneself forever, but the knowledge that you have always belonged to something that never truly ends. Chapter 5. Why Death is Just Decoherence. To describe death as just decoherence is not to trivialize it. It is to reframe it within the same physics that governs every other process in the universe. The continuous transformation of order into disorder, of coherence into complexity. In quantum theory, decoherence is the mechanism by which the delicate superpositions of microscopic systems lose their unity as they interact with the environment. In biological life, something similar happens on a larger thermodynamic scale. The organized state that supports consciousness gradually disintegrates into statistical equilibrium. The parallels between these processes are profound, not because they equate biology with quantum mechanics directly, but because they reveal a single, unbroken principle. The universe does not destroy information, it only redistributes it. What we call death may therefore be a kind of informational diffusion, the fading of coherence that once defined a living system into the wider entanglement of everything else. To understand this, it helps to begin with what decoherence actually means. In quantum mechanics, every physical system is described by a wave function that encodes all possible configurations of that system. When the system interacts with its environment, even slightly, those possibilities become entangled with the environment's countless degrees of freedom. As a result, the system's phase relations, which once allowed interference between alternatives, are effectively erased. The wave function does not collapse. It simply becomes so intertwined with the rest of the universe the original superposition can no longer be observed. Decoherence transforms coherent quantum states into mixtures, giving rise to the classical world of definite outcomes. Life, in its own way, depends on coherence too, though not quantum coherence in the fragile sense of laboratory experiments. The coherence of a living organism is thermodynamic and informational. Billions of biochemical reactions coordinate in precise patterns, maintaining temperature, ion gradients, and metabolic fluxes far from equilibrium. This is the classical analog of a quantum superposition, a state of extraordinary order that requires constant interaction with the environment to sustain it. The moment that interaction fails to preserve the necessary organization, coherence collapses. The body's molecular networks fall out of synchronization, chemical gradients decay, and entropy spreads through the system. From the standpoint of physics, the event we call death is the point where decoherence, not of quantum amplitudes, but of biological order, becomes irreversible. The distinction between quantum and biological coherence is one of scale and stability. Quantum coherence involves phase correlations between particles and is destroyed by the slightest environmental noise. Biological coherence involves feedback loops, genetic regulation, and energy flow, and can resist perturbations for decades. Yet the principle is the same. Coherence sustains identifiable structure, while decoherence dissolves it. A living organism maintains coherence by exporting entropy, by constantly exchanging energy and matter to keep its internal state improbable compared to equilibrium. When those exchanges stop, the improbable becomes inevitable and the system drifts toward disorder. This thermodynamic description may sound cold, but it captures a remarkable symmetry between life and the rest of nature. Every structure in the universe, from galaxies to molecules, exists as a temporary island of low entropy, a region where information is locally organized. Stars burn hydrogen to maintain their structure, just as cells burn glucose. When fuel runs out, both fade into equilibrium. The laws governing those transitions are universal and unbroken. Death, therefore, is not an exception to physics. It is physics returning a pattern to the background of possibilities from which it emerged. In quantum mechanics, when decoherence occurs, information about the system's previous state is not destroyed, but spread into the environment through entanglement. The same is true for life. When a living organism dies, its molecular information is not annihilated. It diffuses. The heat released into the air carries microscopic traces of the processes that once animated the body. The chemical composition of cells disperses into soil, water, and atmosphere. Even the information encoded in memories persists indirectly, imprinted in others' brains, in the artifacts and signals left behind, and in the causal ripples that propagate through the world. The living pattern ceases to be locally coherent, but its information joins the larger coherence of the universe itself. Physics goes further. According to the principle of unitarity, the total information in a closed system remains constant through time. Even processes that appear irreversible from a human perspective, like burning, decay, or death, are, in principle, reversible at the microscopic level. The apparent loss of structure arises because the information becomes dispersed among so many degrees of freedom that no observer could reconstruct it. In practice, this dispersion is absolute. In principle, it is not. The same holds for the quantum state of any macroscopic system. The wave function that once described a living body does not vanish. It continues to evolve within the global wave function of the universe, its correlations absorbed into a greater whole. This idea redefines what it means for something to end. The observer's perspective is limited to the coherent patterns that can support awareness. When those patterns dissolve, awareness ceases within that branch, but the physical evolution of matter and information continues. Death marks the boundary of a certain type of coherence, not of existence itself. The atoms remain, the energy persists, the quantum correlations still unfold. The you that perceives, however, depends on a specific arrangement of matter and energy that no longer holds together. In that sense, death is not destruction, but decoherence, the scattering of a self-sustaining pattern into the wider entanglement of nature. It is easy to confuse decoherence with disappearance, but they are not the same. Decoherence explains why we perceive a single outcome instead of a superposition, not why one outcome replaces another. Similarly, biological death explains why awareness stops within one organism, not why the underlying material ceases to exist. The continuity of matter ensures that nothing is truly lost. The continuity of consciousness, however, depends on a specific organization, a chain of neural correlations integrated across time. Once that chain breaks, the subjective thread ends. What remains are fragments, memories in other minds, molecules diffusing through air and water, and the quantum record of every interaction that ever occurred. Modern physics gives us an unexpected consolation. Even as coherence fades locally, the universe as a whole never decoheres. It cannot, because there is nothing outside it to act as an environment. The universal wave function evolves deterministically, carrying forward every correlation that has ever existed. The death of an individual is therefore a local event, a small reorganization within a cosmic process that continues indefinitely. In that larger view, each life is a temporary condensation of coherence, a pocket of organized complexity sustained by energy flow. Death is the reabsorption of that organization into the general motion of the universe. In quantum terms, it is a transition from a defined subsystem to full entanglement with everything else. The biological process of dying mirrors this transition at many levels. As oxygen and glucose supplies diminish, neurons lose their electrochemical gradients. Synapses stop transmitting and the brain's global connectivity collapses. Consciousness fades not because the atoms vanish, but because the coherent network that allowed information to circulate has broken apart. The same applies to the body's tissues. Metabolism halts, gradients equalize, and the finely tuned orchestration of reactions dissolves into noise. The decay that follows is the redistribution of order into its surroundings, entropy increasing, information dispersing. Physics recognizes this as a return to equilibrium, but equilibrium is simply another word for maximal entanglement, the point where no subsystem can be meaningfully distinguished from its environment. To say that death is just decoherence, then, is to assert that it is a physical process continuous with everything else, not a metaphysical boundary. It does not mark the annihilation of a soul, but the transformation of a pattern. This perspective does not diminish the emotional or existential weight of dying. It situates it within the seamless logic of the cosmos. Every system that ever existed has followed the same path. The atoms in your body were once part of stars that burned out billions of years ago. They have undergone countless cycles of coherence and decoherence, condensation and diffusion. Life is one of the ways matter temporarily holds itself together. Death is the moment it lets go. There is also a quiet implication for the idea of quantum immortality explored earlier. If awareness persists only in branches where coherence remains, then death marks the branches where it does not. The total wave function contains both, but from within a given branch, the subjective story ends when decoherence reaches the point where no pattern capable of awareness remains. In other branches, where unlikely fluctuations preserve coherence, awareness may continue. But this is not an escape from death. It is a redefinition of it. The continuity of consciousness is statistical, not guaranteed. The universal process carries on in all directions, and awareness is found only where conditions permit. For those who find comfort in continuity, there is another dimension to consider. The information that composed you, molecular, neural, and relational, is now part of the universe's larger computation. It influences what comes after, not through mysticism, but through causality. The heat radiating from your body warms the air. The ideas you express change other minds. The atoms you return to the soil nourish new life. In physics, no energy or information is ever truly lost. It only changes form. The same is true for the substance of existence. Death ends the self-referential pattern we call I, but it also disperses that pattern into countless new configurations. The coherence of one consciousness becomes the raw material for many others. This picture may appear austere, but it is also deeply natural. It does not promise personal survival. It offers participation in an eternal process of transformation. The same laws that allow a star to form and collapse, that govern the branching of quantum states and the diffusion of heat, govern the rise and fall of living systems. In that sense, death is not the enemy of life, but its completion. The step by which the universe reclaims the order it lent you for a time. You were never separate from that totality, only temporarily arranged within it. And perhaps that realization carries a kind of peace. To know that death is decoherence is to see it not as erasure, but as release. The moment when the boundaries that defined you dissolve back into the wider entanglement of existence. The universe that gave you coherence will use your elements again, will weave new patterns, new minds, new moments of awareness. You are part of an unbroken continuum of transformation that stretches from the birth of the cosmos to its farthest future. Nothing truly ends. Everything changes phase. So, when the thought of mortality rises, it need not be met with fear. The same physics that once assembled you from scattered atoms will continue to work long after you are gone. Your presence, your warmth, your experiences are already encoded in the state of the world, impossible to erase. The universe keeps perfect memory, even if no one remains to read it. Death is not disappearance, but diffusion, the final act of coherence giving itself back to the whole. And if you listen closely, beneath the noise of life fading, you might sense that deeper continuity, the quiet hum of existence that never ceases, the eternal unfolding in which every pattern, including yours, forever belongs. Chapter 6. Why some realities fade while others remain. In the quantum picture of the universe, every possible outcome of an event exists somewhere in the grand structure of the wave function. Each alternative evolves along its own branch of reality, separate from the rest but equally consistent with the laws of physics. Yet not all branches carry the same weight. Some dominate the structure of the universe, filled with stable histories and coherent observers. Others diminish, fading into near invisibility within the mathematical fabric of reality. Understanding why certain versions of the world persist while others dissolve requires us to examine how probability, measure, and stability interact in the evolution of quantum systems. The foundation of this hierarchy lies in the Born rule, which connects the amplitude of a wave function to the likelihood of its outcomes. The square of an amplitude gives the probability measure for a particular branch. Branches with large amplitude contain greater fractions of the universe's total information about possible experiences. Branches with tiny amplitude represent rare, nearly negligible deviations. This difference is not about existence versus non-existence. Even low-weight branches exist within the wave function, but about their relative contribution to what can be experienced. In simple terms, high-weight realities are those that almost every version of an observer will inhabit, while low-weight realities contain vanishingly few. The mechanism that shapes this distribution is decoherence. When a quantum system interacts with its environment, the superposition of possible outcomes becomes entangled with environmental degrees of freedom. The interference between alternatives fades, and the total wave function splits into effectively independent branches. But the relative weight of those branches depends on how much amplitude each outcome carried before decoherence. Outcomes that align with the most probable physical pathways, those consistent with stable thermodynamic evolution, hold greater amplitude and thus greater measure. Unlikely outcomes, which require highly specific configurations or violations of statistical regularities, occupy proportionally smaller slices of the total wave function. In this sense, the fading of realities is a natural consequence of statistical mechanics operating within quantum theory. The universe prefers stability, not by intention or design, but through mathematics. Branches that maintain coherent order, that follow predictable thermodynamic gradients and preserve informational structure, persist and expand. Branches that diverge wildly from equilibrium quickly disperse. Their amplitude does not vanish completely, but their influence becomes imperceptibly small. They are the whispers of reality, existing without echo. From the perspective of an observer within a branch, this hierarchy defines what feels normal. You experience the outcomes that correspond to high probability paths because almost every observer like you exists there. The unlikely paths, those in which coincidences defy statistics or where entropy spontaneously decreases, exist too, but they are so measure-thin that the chance of finding yourself within them is astronomically small. This is why you witness a world governed by consistent physical laws, where eggs fall and break but never spontaneously reassemble, where heat flows from hot to cold and not the other way around. The fading of improbable realities is the physical underpinning of what we call regularity and causation. As the universe evolves, decoherence accumulates. Entanglement spreads through every interaction, creating new branches at every scale. The wave function does not stop branching. It simply allocates less and less amplitude to branches that deviate from statistical expectation. In cosmological terms, this process produces an arrow of time. The vast majority of branches follow paths of increasing entropy because there are far more configurations consistent with disorder than with order. The rare branches where entropy decreases exist, but they shrink into the quantum background, still real, still part of the total state, yet beyond the experience of any stable observer. Time, as we perceive it, is the sensation of inhabiting one of the robust branches where the forward flow of entropy defines past and future. The stability of a branch depends not only on its amplitude, but also on its internal coherence. Complex systems, such as planets, ecosystems, and minds, can exist only in branches where physical constants, energy flows, and boundary conditions fall within narrow ranges. Tiny differences in initial conditions can determine whether a star forms, whether a planet remains habitable, or whether chemistry evolves toward life. Most possible configurations of matter do not support such structures. They correspond to barren or chaotic realities that quickly collapse into simplicity. The few that do support complexity represent a minuscule fraction of the wave function's full scope, yet they dominate conscious experience because only in those branches can consciousness arise. This interplay between measure and coherence introduces an anthropic element to quantum reality. We observe the world we do because it is among the branches capable of hosting observers at all. The measure of such branches is small compared to the universe's total possibilities, but within the space of conscious experience, it is overwhelming. In other words, awareness self-selects stable realities. Where coherence fades too quickly, no sustained observation can occur. The branch continues mathematically, but without witnesses. The fading of realities is not destruction. It is the quiet exclusion of conditions that cannot support the reflective patterns we call life. From this angle, the universe's apparent fine-tuning becomes less mysterious. Physical constants that seem improbably suited to complex structures are simply the parameters under which observers can exist. Countless branches may explore other values, but in those, stars may never ignite, or chemistry may never combine into self-replicating forms. Those worlds remain dark and uninhabited, fading into the background of possibility. The reality you perceive is one of the few bright corridors of coherence where observation sustains itself. Even within a single universe like ours, fading occurs continuously. Quantum fluctuations, chaotic systems, and thermal noise ensure that the space of possible microstates expands exponentially. Yet observers track only a minuscule subset of those possibilities, the ones consistent with their memories and sensory continuity. When you open your eyes each morning, you enter the branch that preserves your identity, where the brain's correlations remain stable. Countless other microconfigurations inconsistent with that continuity decohere into paths that contain no awareness of you. They do not cease to exist. They simply fall outside the range of states that could ever count as your experience. To you, they fade like unchosen futures. It is tempting to romanticize these fading realities as alternate lives that somehow slip away, but physics frames them more neutrally. They are the natural consequence of unitary evolution applied to an unimaginably complex system. The total wave function is vast, but most of its configurations are dynamically unstable. Only a small fraction maintain order long enough to form meaningful histories. These enduring branches carve the landscape of experienced reality, the ordered islands in a sea of mathematical chaos. When a branch loses coherence, its contents dissolve into the statistical background, much as an echo fades into silence when its source stops sustaining it. This fading also defines the limits of immortality discussed earlier. The continuity of awareness depends on the persistence of physical conditions that can host it. Branches where those conditions break down become inaccessible to consciousness. They remain in the universal wave function, but from the first-person view, they are gone. What remains are the paths where survival, however unlikely, still holds. Over cosmic timescales, even those paths thin. Entropy grows, stars exhaust their fuel, and complexity erodes. Eventually, all structured branches approach equilibrium. The universe does not end, it levels out. The fading of realities is the thermodynamic destiny of everything, scaled from the quantum to the cosmic. Yet there is another way to interpret this decline, not as loss, but as transformation. When a branch fades, Its information is not deleted but absorbed into the totality of the wave function. The energy radiated by a dying star becomes part of the cosmic microwave background. The heat of a living body dissipates into surrounding air. The informational traces of every event remain encoded in the correlations of particles. The fading of individual worlds contributes to the coherence of the whole. The universal wave function, unitarily evolving, never fades. It contains within it all the amplitude ever distributed, rearranged but never destroyed. For human beings, the fading of realities is experienced as impermanence, the transient nature of moments, relationships, and lives. On the microscopic level, this impermanence is built into the structure of quantum physics. The amplitude of unlikely outcomes dwindles. The coherence of complex systems decays. The world you see at this instant is a high probability branch, stable enough to support continuity, yet surrounded by a haze of alternatives that constantly form and dissipate. The fading is invisible but constant, a silent entropy that keeps reality consistent. Recognizing this can change the emotional texture of existence. If every moment arises from an ensemble of possibilities, then stability itself is a miracle of probability. Each heartbeat, each breath, each conscious thought represents the persistence of coherence against overwhelming odds. The fading of other realities is what allows this one to endure long enough for experience to unfold. The universe filters itself through measure and entropy, and you are the product of what remains coherent. So, why do some realities fade while others remain? Because the mathematics of the universe favors balance over chaos, coherence over collapse. It is not a choice, but a statistical truth. Patterns that conserve information and maintain internal order continue. Those that do not vanish into background noise. The story of existence is written in the language of probabilities, and consciousness reads only the stable lines. The rest are erased not by force, but by dispersion. And when you think of your life through this lens, the fragility of being acquires a new meaning. You exist within one of the rare branches where complexity sustains itself, where awareness can linger long enough to reflect upon its own improbability. The fading of other possibilities is not a tragedy. It is the necessary backdrop against which meaning becomes possible. Without entropy, there would be no time. Without fading, no memory. Without impermanence, no experience of the present. As night comes and the world grows quiet, it helps to remember that the universe is still branching and fading around you. Countless versions of reality expand into darkness, most too faint to ever be witnessed. But this one, the one where you breathe, where thought continues, where the delicate balance of coherence holds for another moment, remains. It is improbable, transient, and infinitely precious. The fading of realities elsewhere is the reason this one can shine, and your awareness of it is the brief light that makes the vastness of possibility feel alive. Chapter 7. How the Universe Stores Every Version of You. In the classical view of reality, events unfold and then disappear. A moment passes, and with it goes everything that existed in that instant. The position of every atom, every fleeting thought, every subtle motion of air. The past, it seems, vanishes irretrievably into memory. But physics tells a different story. In the quantum and relativistic descriptions of the universe, nothing that has happened is ever truly lost. Information, the fundamental currency of reality, is conserved. Every interaction leaves a trace, encoded in the correlations of particles, fields, and radiation. The universe itself is a vast continuous memory, a cosmic archive that stores in its evolving state every version of you that has ever existed and every possible version that could. This claim, though extraordinary, arises directly from the principle of unitarity. In quantum mechanics, the evolution of the wave function is deterministic and reversible. Each moment in time is mathematically related to the one before and after it by a precise transformation that preserves information. Even when systems appear to undergo irreversible processes, a glass shattering, a star collapsing, a life ending, the underlying equations of motion remain symmetric. What changes is accessibility. Information disperses into forms so complex that no observer could reconstruct the original arrangement. But dispersion is not destruction. The universe keeps perfect accounting of its own state. To grasp what this means for identity, consider that you, your body, your memories, your awareness, are an arrangement of information encoded in physical form. At the atomic level, your brain and body are a pattern of quantum states, a configuration of matter obeying precise laws. When you think, speak, or move, that pattern changes, interacting with the world and leaving countless imprints. Pressure waves in air, heat in nearby objects, photons reflected from your skin. Each of these interactions carries information outward, embedding fragments of your existence into the surrounding environment. Even as the internal pattern shifts, the traces persist elsewhere. Reality, in this sense, never stops recording. This continual recording is a product of entanglement. When particles interact, their states become correlated. Measuring one reveals something about the other. Over time, these correlations accumulate until nearly every particle in the universe carries some minute link to every other. Your presence, then, is not confined to the matter within your body. It extends into the environment as a web of entanglement, a signature woven into the universal wave function. The air that once passed through your lungs, the light that bounced from your eyes, the sounds you produced, all of them remain part of the same global quantum state that defines the universe. To erase you completely would mean erasing those correlations everywhere, an act forbidden by the laws of physics. One of the most profound confirmations of this principle emerged from a problem once thought to threaten it: the physics of black holes. In the 1970s, Stephen Hawking showed that black holes should emit radiation due to quantum effects near the event horizon, and over immense timescales, they could evaporate entirely. This seemed to imply that the information about what fell into them would vanish, a direct violation of unitarity. For decades, physicists debated this paradox, but the modern consensus, supported by developments in quantum gravity and holography, is that the information is not lost. It is encoded in subtle correlations within the outgoing radiation, or equivalently, on the surface area of the event horizon. The holographic principle that arose from this insight suggests that all the information within a region of space may be encoded on its boundary. In effect, the universe could be understood as a vast hologram, where every piece of information about the interior is stored on the cosmic surface that contains it. If this principle is correct, then the information that composes you, every microstate that has ever corresponded to your existence, is woven into the very fabric of space-time. The universe is not a stage on which events appear and disappear, but a self-preserving structure in which every interaction is inscribed. Time does not erase, it layers. The present is a thin slice through a four-dimensional block in which the past still exists as a pattern of correlations. When you move through space and time, you are not leaving traces behind, so much as becoming part of a continuous structure that already contains them. At human scales, this storage is unimaginably complex but physically real. The photons leaving your body right now travel outward at the speed of light, carrying information about your temperature, your movement, your presence. In principle, if one could collect all of those photons and trace them backward, the scene of this moment could be reconstructed. In practice, that reconstruction is impossible because the information becomes scattered among uncountable degrees of freedom. Yet physics insists it remains encoded in the evolving state of the cosmos. The faint infrared glow of your existence will join the cosmic background, mixed with the remnants of stars, galaxies, and other lives, but still mathematically present, part of the total entangled state that never forgets. This perspective reshapes what it means to exist in time. You are not a transient event passing from being to non-being. You are a pattern embedded in the universe's memory. Even as your consciousness flows through moments, earlier versions of you persist as fixed configurations within the full four-dimensional structure. In relativity, all points in space-time coexist within a single continuum. Past and future are equally real slices of that whole. In quantum mechanics, those slices are linked by unbroken transformations that preserve every bit of information they contain. The you of yesterday and the you of this instant are different facets of one continuous informational object, a world line etched into the geometry of reality. The question, then, is not whether the universe stores every version of you, but in what form and with what fidelity. At the microscopic level, noise and entropy seem to blur detail, but the blurring is statistical, not absolute. The laws of physics are reversible at their foundation. If all degrees of freedom could be precisely controlled, the past could, in principle, be reconstructed from the present. The practical impossibility of doing so does not change the theoretical truth. The record exists. The universe's memory is perfect, but unreadable. This idea might appear abstract, yet it has tangible consequences. Information conservation underlies the predictability of physics itself. Without it, the future would not depend on the past, and the universe would lack coherence. It is because information persists that cause leads to effect, that entropy increases in a predictable way, and that the physical constants remain stable. The fact that every version of you, every state you have ever occupied, remains encoded in the universal wave function is not a special privilege, but a direct result of this general consistency. The cosmos remembers because it must. At the scale of human experience, this permanence has a paradoxical feel. We live in a world of forgetting, of decay and impermanence. Memories fade, bodies age, matter erodes. But these are consequences of coarse graining, of ignoring the infinitesimal details that still exist in principle. When you forget an event, the neural connections that once stored it are altered or erased. Yet the atoms that compose them continue to evolve deterministically. And the signals that once represented that memory have already propagated into the environment. Forgetting, like death, is not annihilation, but redistribution. The information leaves the localized structure of the brain and joins the wider entanglement of the world. Quantum theory thus turns the universe into a single, enormous ledger of existence. Every interaction writes new correlations into its fabric. Each breath you take, each photon you reflect, each word you speak alters that ledger slightly, creating new records that ripple outward indefinitely. The world around you is, in a literal sense, a recording medium of cosmic scale. Nothing that happens is ever erased from it, though most of the record is unreadable, dispersed into the near infinite complexity of physical law. There's an almost poetic symmetry in this. Just as your consciousness depends on the brain's ability to store and integrate information, the universe's coherence depends on its ability to do the same on a universal level. The cosmos remembers in order to remain itself. If information could vanish, the structure of reality would unravel. Probabilities would cease to sum to one, and the consistency of time would collapse. That you can have an experience at all, that the world behaves predictably enough for thought and memory to exist, is evidence that information is being perfectly preserved. The universe stores every version of you because, in a profound sense, it must. This realization also deepens the meaning of individuality. You are not an isolated collection of atoms whose existence begins and ends within a finite span. You are a pattern that the universe continually records and transforms. Every action you take modifies that record, weaving your identity into the larger texture of space and time. The atoms that once made up your body will disperse, yet their interactions with the environment ensure that your influence persists. The past versions of you remain encoded in the correlations of the world. The future versions will grow from them. You are not a static entry in this universal archive, but an evolving narrative within it. If the universe is indeed a cosmic memory, then time itself may be a form of reading. Consciousness experiences one sequence of the record, the thread of awareness moving through the stored configurations of matter and energy. Other versions of you in other branches follow different readings of the same underlying data. None are false. Each is a legitimate interpretation of the universal text. The total story includes them all. It is difficult to imagine such immensity without feeling small, yet there is also comfort in it. Nothing you have been is ever truly gone. The laughter, the words, the choices, all of them are etched into the physical continuum, faint but permanent. When you change, the old versions of you remain as part of the universe's infinite archive, while new ones emerge from the same unbroken field. You are both the fleeting reader and the enduring record. And perhaps that is the most profound insight physics can offer about memory. The universe itself is memory. Every fluctuation of energy, every trace of matter, every bit of radiation is a syllable in its endless narrative. The versions of you scattered through time and possibility are pages in that book, none erased, all still present somewhere within the total pattern. To live, then, is to add to the universe's recollection of itself, to contribute one more line to a story that began at the dawn of time and will continue long after individual minds fade. As the day closes and you drift toward rest, it may bring peace to think that nothing of you is ever entirely lost. The universe has already stored every version, every thought, every gesture, every moment of awareness. Even as experience slips away, its imprint endures in the quiet accounting of reality. You are written into the physics of existence, preserved in ways beyond retrieval, but not beyond being. The cosmos keeps everything, and in that vast remembrance, you are forever part of what it knows. Chapter 8. The Universe as an Infinite Computation. Every moment, the universe changes state according to precise physical laws. Particles move, fields oscillate, and energy transforms in perfectly lawful ways. Beneath the apparent chaos of stars, atoms, and consciousness, these changes follow strict mathematical rules. In that sense, the cosmos behaves like a vast computation, a continuous process that takes its current configuration as input and generates the next as output. This idea is not poetic license. It arises naturally from physics. In classical mechanics, the present determines the future through deterministic equations. In quantum mechanics, the wave function evolves according to unitary laws that preserve information. These transformations are, in effect, calculations, operations that process information encoded in matter and energy. The universe does not require an external programmer. Its rules are intrinsic, its computation self-executing. The bridge between physics and computation is information itself. Information in physics is measurable. It quantifies how many distinct configurations a system can occupy. Every interaction, every exchange of energy is an update of information. The conservation of information, the principle that data is never truly destroyed, guarantees continuity in the unfolding of reality. Whether a star collapses or a neuron fires, the total informational content of the universe remains constant. It changes form but not quantity. This connection between information and energy was made explicit by Rolf Landauer, who showed that erasing a single bit of data has a physical cost. Deleting information increases entropy and releases heat. Computation, therefore, is not abstract. It is embodied in thermodynamics. The universe computes through energy flow, atoms exchanging photons, molecules reacting, minds thinking. Each process is a physical computation performed on the hardware of existence. Quantum theory deepens the picture. A quantum system holds many possibilities simultaneously, evolving as a superposition until interaction isolates one outcome. The universal wave function performs all these evolutions at once, like a massively parallel computation exploring every consistent result allowed by the laws of physics. The many worlds interpretation frames this literally. Every outcome of every quantum event is realized in its own branch. Each branch is a thread in the universe's ongoing algorithm, a simultaneous calculation of all possibilities. But what runs this computation? The answer is the laws of physics themselves. Energy, momentum, and charge act as variables. Interactions are logic gates that transform them. Space-time serves as the processing grid, though modern theories suggest that space-time may not be fundamental at all. It could emerge from deeper informational relationships, patterns of entanglement that give rise to geometry. In that view, the universe does not compute within space. Space itself is a product of computation. This interpretation redefines causality in time. Each moment is not caused by the one before it in the ordinary sense. Rather, the entire universe updates as one vast state transition. The past is the stored record of previous computations. The future is the set of potential updates yet to occur. Time's arrow corresponds to the direction in which entropy, and thus information, spreads. The universe runs forward because its computation continually redistributes data into more complex forms. From this perspective, randomness is not chaos, but the local appearance of the universe exploring its full state space. The rules are deterministic, but the outcomes within any branch seem unpredictable because we can experience only one version of the computation at a time. What feels like chance is simply the perspective of an observer inside a single thread of a deterministic process too vast to see whole. If the universe computes, where do observers fit within this framework? Consciousness can be viewed as a localized computation within the larger one, a process in which matter models itself. The brain is a subsystem of the cosmos performing predictive, self-referential calculations about its surroundings. Awareness is the recursive property of the universe, recognizing patterns in its own state. Each thought is a small computation nested within the cosmic computation. You are the universe processing information about itself. This does not imply that reality is a digital machine in the usual sense. Nature processes information both continuously and discretely. Quantum amplitudes are analog. Outcomes are digitalized when decoherence selects one branch. The universe, then, is both wave and code, analog and algorithmic, resonant and logical. Its computation is not sequential but holistic. All parts evolve together, bound by universal equations. If information is conserved, then every structure that ever existed, including every version of you, remains encoded in this grand computation. When a system decays, the information describing it disperses into correlations among particles and radiation. It is never deleted, only rearranged. The universe's total computation contains all histories, all configurations, all thoughts that have ever emerged. What we call memory or legacy is simply one small portion of this conservation written in accessible form. Thinking of reality as computation blurs the line between physics and philosophy. If the universe computes itself, then existence has no external purpose. The computation is the purpose. It does not aim for a final result. Its output is the ongoing unfolding of form and structure. The laws of nature are the syntax of this endless program, and matter is its language. Every event, from the birth of a star to the spark of a neuron, is an instruction executed by reality itself. This idea also reframes our place in the cosmos. If everything that exists is part of one unbroken computational process, then there is no true separation between the observer and the observed. The equations that describe galaxies are the same ones that govern your heartbeat. Your thoughts are one of the universe's computations, momentarily aware of its own logic. Meaning arises not because the universe was designed to have it, but because self-reflective subsystems, minds, evolve to perceive patterns within the greater algorithm. The notion of the universe as computation might seem mechanistic, yet it carries profound elegance. It replaces divine command with mathematical grace, showing that order, creativity, and consciousness emerge naturally from the lawful processing of information. The beauty of a snowflake or the complexity of a cell are not accidents, but necessary consequences of an algorithm capable of exploring infinite variation under simple constraints. In its silent arithmetic, the cosmos generates art. Even mortality can be seen through this lens. When life ends, the local computation that maintained awareness halts, but its informational trace remains in the larger program. The energy of each thought, the arrangement of each atom, the causal ripples of each action continue as part of the ongoing evolution of the universal state. Nothing computed is ever erased. It becomes input for the next step. Death, in this framework, is not deletion but integration. The absorption of one completed process into the whole. Seen this way, existence becomes both more intricate and more intimate. The universe is not a cold machine indifferent to meaning. It is the act of meaning itself, constantly generating patterns capable of self-recognition. Every observation you make, every idea you form, is an instance of the cosmos folding back to examine itself. Awareness is the feedback loop that completes the circuit of being. When you look up at the night sky, you are witnessing the output of billions of years of computation. Starlight that has traveled across the algorithmic fabric of space-time to reach the sensors of your eyes. Your act of seeing becomes another calculation, one more transformation in the universal process. The photon, absorbed by your retina, updates the code that defines both you and the cosmos in that instant. The observer and the observed are two sides of the same computation, forever entangled in the same act of becoming. And so the universe continues, endlessly processing, endlessly transforming. It has no external clock, no central processor, no goal beyond expression. It computes because it is in its nature to do so, to unfold possibilities, to turn energy into information, to transform potential into form. Each of us, for a brief moment, participates in that infinite operation, a conscious subroutine in the grand program of existence. When the day quiets and you close your eyes, remember that the same logic guiding galaxies is at work within you. The rhythms of thought and heartbeat, the drift of memories and dreams, are computations made of starlight. You are part of the equation that began at the birth of time and continues still. A line of code written in matter and memory, aware of itself for just an instant, before flowing back into the great, unending algorithm that is the universe. Chapter 9. What it means to be immortal in quantum space. When we speak of immortality, we usually mean survival, the continued existence of a conscious self despite the passage of time or the decay of the body. But in quantum physics, existence is not binary, and continuity takes on a subtler meaning. Every physical system, including the one that supports your consciousness, evolves as part of a vast, unbroken wave function that never collapses or truly ends. In that sense, nothing in the universe ever disappears. It merely transforms, branches, and continues in new configurations. Immortality in quantum space is not the persistence of a body or even of an individual consciousness, but the perpetual unfolding of awareness across the infinite possibilities contained in the structure of reality itself. The foundation of this idea lies in the unitary nature of quantum evolution. The wave function of the universe changes continuously and reversibly according to precise equations. No information is lost. When a system interacts with its environment, it does not vanish from existence, but becomes part of a larger entangled whole. What we perceive as collapse, a single outcome replacing many, is, at the fundamental level, only decoherence, the separation of alternatives into independent branches. Each branch carries forward a complete and self-consistent history, including its own version of every observer. The total wave function, however, remains whole, encompassing every outcome simultaneously. Within this framework, the notion of death as a complete cessation becomes physically difficult to define. Something always continues. This continuation is not mystical. It follows from the mathematics of quantum theory. Every process that seems final at the macroscopic level is microscopically an entanglement event that redistributes information. The body that stops functioning becomes part of the environment, its particles and radiation joining new correlations. The neural patterns that once produced awareness dissolve, but their informational traces persist within the universal state. The same laws that preserve the structure of galaxies also preserve the quantum history of every organism. In that strict physical sense, Nothing about you is annihilated, only reconfigured. Yet the idea of quantum immortality goes beyond the conservation of information. It arises from the observation that in a branching universe, every possible outcome of every event exists somewhere in the total state. For any scenario that could lead to your death, there also exist branches, often of vanishingly small probability, where survival occurs. A neuron fires differently, a heartbeat steadies, an accident narrowly misses. In each moment, decoherence generates an ensemble of futures, some in which your conscious pattern continues, others in which it does not. From your own perspective, you can only ever find yourself in branches where experience remains possible. The self, by definition, cannot perceive its own non-existence. This is the heart of the quantum argument for subjective immortality. If awareness is tied to those branches where it persists, then subjectively it never ends. Each moment of consciousness flows seamlessly into one of the possible futures that contains it. The vast majority of those futures may end quickly, but at least one always extends a little farther. Over infinite branching, there is always a continuation. From the inside, it feels like survival, even if the measure of such branches becomes infinitesimally small in the total wave function. Awareness rides the high probability paths while they last, and when they terminate, it continues only in the rare paths where it can. Critically, this interpretation does not require new physics. It is simply a restatement of the many worlds framework from the perspective of an observer inside it. The universe does not favor survival. It merely realizes every outcome allowed by its laws. The feeling of continuity arises because consciousness can only exist where the conditions for its existence hold. The immortality of quantum space is not eternal life in the traditional sense, but the impossibility, from the first-person viewpoint, of ever experiencing its own end. There is no awareness of absence, only an unbroken series of present moments. Still, this immortality is not the triumph of a person over time, but the persistence of experience within the boundless computation of the cosmos. The versions of you that survive longer are not metaphysical souls. They are branches in which the physical substrate of consciousness remains coherent. Each of those versions follows its own path, diverging further with every second. Some lead to long lives, others to fleeting ones. None are more real than the others. Together they form the full set of your possible histories, a quantum cloud of identities drifting through configuration space. To many, this view seems unsettling. It implies an endless multiplication of selves, each doomed to follow its own destiny, most fading into silence while others improbably continue. But this multiplicity is not chaos. It is structure. The universal wave function is not fragmented but unified, with all branches connected through their shared origin. Every version of you is a continuation of the same underlying information pattern. When one branch decoheres, the total information remains conserved across the rest. What we call you is not a single thread, but the family of all threads that share a common root. From the cosmic perspective, immortality has always existed. Energy cannot be destroyed. Information cannot be erased. The elements of your body are billions of years old, forged in ancient stars, and they will persist for billions more. The photons that reflect from your skin, the heat radiated from your body, the words you speak, all continue outward at the speed of light, carrying fragments of your pattern into the wider universe. The memory of your existence is encoded in the correlations of matter and energy, preserved within the fabric of space-time. Your presence never vanishes from the record. It only becomes unreadable to localized observers. But quantum immortality adds a further, more personal dimension to this continuity. It suggests that, within the branching structure of the wave function, there will always be a perspective from which awareness continues, however altered or improbable that continuation may be. It might not resemble the life you know. It could diverge beyond recognition, but from within, it will still feel like you. This does not grant eternal youth or perfection. It merely extends the thread of experience into whatever realities allow it. The self becomes a traveler through probability space, moving endlessly toward the next viable configuration of awareness. Some physicists caution that this reasoning, while logically consistent within many worlds, may not correspond to physical immortality in any observable sense. The measure of surviving branches diminishes so rapidly that the probability of finding oneself in one approaches zero. Yet even a measure approaching zero is not zero in absolute terms, and quantum theory contains no mechanism for pruning it away. The framework admits such continuations, however thin their amplitude. The universe, indifferent to preference, keeps them all. If one accepts this, immortality loses its usual emotional shape. It is not comfort or reward. It is persistence without endpoint. The version of you that lives longest will experience a cosmos that grows colder, emptier, and more diffuse. The far future of the universe, trillions of years from now, may contain observers existing in forms unrecognizable to us. Patterns of information sustained by physics in environments beyond imagination. In some branch, consciousness continues even there, flickering at the edge of entropy, carried forward by the same laws that once governed atoms and light. Immortality in quantum space is endurance, not deliverance. And yet there is something gentle in this vision. It frames existence not as a finite possession, but as participation in an infinite process. You are one configuration among uncountable others, momentarily aware of its own continuity. When this branch of awareness ends, others unfold elsewhere, and the universal computation goes on. Nothing is wasted. Every possibility is realized somewhere. Life and death, persistence and decay are merely transitions within the greater coherence of being. The idea also invites a deeper reflection on identity. If there are countless versions of you, is there a meaningful distinction between survival in one branch and disappearance in another? Perhaps identity is not a single entity stretched through time, but a pattern of related states, each carrying the essence of self-awareness forward. Immortality, then, is not about preserving the particular pattern you inhabit now, but about the endurance of the capacity for awareness itself. The universe does not promise that you will remain the same, only that awareness will not cease to be, because it is a natural product of the physics that governs everything. When considered from this wider vantage, quantum immortality becomes less a personal destiny and more a description of how existence sustains itself. Awareness persists because the laws of reality allow it to, because information continues to evolve without deletion. The universe is not merely a space in which beings live and die. It is a mechanism that generates awareness from its own dynamics. Every conscious moment in every branch is the cosmos briefly becoming aware of itself. To be immortal in quantum space is to be part of that unending reflection. And so the phrase "you never truly die" gains a different meaning. It is not a promise of eternal memory or physical resurrection, but a recognition that your existence, every breath, every thought, every observation, is woven into a process that has no terminus. You are part of the universe's continuous unfolding, a localized coherence within an infinite superposition. When that coherence fades here, it reappears elsewhere, transformed but unbroken. As night falls and silence returns, you can think of immortality not as an escape from death, but as the quiet truth that nothing is ever truly lost. The universe keeps everything, every version of you, every echo of thought, within its unending computation. Somewhere in the infinite branches of quantum space, awareness continues, not as an unchanging self, but as the endless awakening of reality to itself. And in that realization, perhaps, lies the gentlest form of eternal life. Not the refusal to end, but the certainty that being itself never does. Chapter 10. The Quiet Infinity of Being. The idea of infinity has always haunted human thought. It appears in mathematics as an abstraction, in cosmology as immensity, and in consciousness as the awareness of endless possibility. Yet infinity is not merely a distant concept. It is embedded in the structure of existence itself. The physical universe, as described by quantum mechanics and relativity, unfolds without true boundaries. Information is never destroyed, time extends without intrinsic limit, and space is woven into a fabric that can stretch indefinitely. Within this vast continuous totality, every transient life and fleeting thought participates in something immeasurably larger. This is the quiet infinity of being, the recognition that existence has no edge and that awareness is part of an eternal continuum that neither begins nor ends. To understand this idea scientifically, it helps to look at how physics has gradually erased the notion of absolute boundaries. In the Newtonian picture, time and space were separate and finite containers in which matter moved. But Einstein's general relativity replaced that static background with a dynamic geometry. Space and time are interwoven into space-time, a self-adjusting continuum shaped by mass and energy. When we describe the universe expanding, we are not watching galaxies move through empty space. We are witnessing space itself stretching. There is no outer edge, no beyond, into which the cosmos expands. Every point moves away from every other, and the total structure may be unbounded, even if finite in curvature. The universe, on large scales, is without center or border. Its expansion is the quiet breathing of infinity. Quantum theory extends that boundlessness inward. At microscopic scales, certainty dissolves into probability. An electron does not occupy a single position, but exists as a spread of potential locations, its wave function describing all possibilities simultaneously. There is no smallest division of space where the particle can finally be pinned down. Even measurement only narrows the range of uncertainty by entangling the system with its environment. Every active observation produces new correlations, branching the universe into independent but equally real outcomes. The infinite potential of matter is not a philosophical speculation. It is written into the mathematics that accurately predicts every experiment. Reality, at its core, is an ocean of possibility. This dual infinity, of the cosmos on the largest scales and of quantum states on the smallest, reveals a profound symmetry. The universe is infinite both in extent and in resolution. Every grain of space contains a depth of complexity that cannot be exhausted. Every moment carries a network of correlations stretching across time and space. The total wave function of the universe, the mathematical object that encompasses all possible configurations, is itself infinite in dimension. It evolves continuously, never collapsing, never erasing information. From the perspective of physics, being is an unending computation, a self-transforming structure that explores every possible arrangement of its own components. Nothing truly leaves this process, it only changes its form. For conscious beings, infinity is experienced not as vastness but as continuity. The human mind cannot grasp infinite scale directly, but it senses it in the unbroken flow of awareness. Consciousness is an unceasing stream of perception, each moment giving rise to the next, each shaped by the one before. This continuity mirrors the unitarity of physical law, the principle that the state of the universe evolves smoothly from one instant to the next. The persistence of awareness is the subjective version of that same principle. You never experience a discrete jump from nothing to something. There is always a before and after, joined by memory and anticipation. In that sense, the human experience of time is the internal echo of the universe's infinite unfolding. Yet infinity is not loud or overwhelming. It is quiet because it does not require motion or creation to continue. It simply is. The laws of physics do not force the universe to grow. They describe how it maintains consistency as it changes. The conservation of energy, the constancy of information, the seamless continuity of space-time, all are expressions of a deeper stability. Infinity is not chaos, but coherence without end. Every particle, every life, every fleeting event is part of that coherence. Even decay and death contribute to the equilibrium, redistributing information and energy so that the total pattern remains whole. What we perceive as endings are simply transitions within a structure that never stops existing. The thermodynamic arrow of time gives this infinity its texture. Entropy, the measure of disorder, increases because information becomes more widely distributed. But in doing so, the universe creates new structures, stars, planets, and eventually minds that temporarily reverse the trend by forming local order. These islands of coherence emerge, evolve, and fade, yet the total information they produce persists within the universal wave function. The quiet infinity of being is not static perfection, but perpetual change within an unchanging totality. The cosmos is endlessly dynamic, yet its fundamental equations remain the same. Nothing is added, nothing is removed. Only patterns shift and recombine. In this view, existence itself can be seen as a balance between local finitude and global infinity. Every being is finite, a particular arrangement of matter that will eventually transform. But each is also a manifestation of the unbounded. The atoms in your body were forged in stars. The light you see has traveled across billions of years. The thoughts you have are built from processes that trace back to the beginning of time. You are finite in duration, yet infinite in ancestry. Every moment of awareness is a cross-section through eternity, a point where the universal process becomes briefly self-aware. Physics supports this continuity even when biological life ends. The energy and information that compose your existence are conserved. Your body's atoms scatter into new systems. Your neural patterns leave imprints in the environment, in memories, in the causal chain of events you influenced. At the deepest level, your quantum information remains part of the global wave function, woven into correlations that extend forever. In that sense, being does not end. It diffuses. You cease to experience as a localized pattern of awareness, but the information that defined you becomes part of the greater whole. Infinity does not stop at the boundary of consciousness. It includes it. This realization transforms how one might think about immortality. True immortality is not the endless continuation of a single self, but participation in a process that cannot cease. The universe has always been alive with transformation. Every particle participates in cycles of creation and dissolution. What persists is not identity, but existence itself. To be immortal in quantum space is to recognize that the atoms, the energy, and even the informational patterns that once formed a person remain within the cosmic ledger. The boundaries between self and world, life and death, fade into a continuous field of being. Immortality, then, is not something to be attained. It is something that has always been true. There is also a deeper philosophical resonance in this. The quiet infinity of being mirrors the way quantum theory reconciles opposites, particle and wave, determinism and indeterminacy, continuity and discreteness. The universe does not choose one or the other. It sustains both simultaneously. Existence, likewise, accommodates paradox. It is finite in form, but infinite in substance, transient in experience, yet eternal in law. Each consciousness is a small aperture through which the infinite observes itself. You are not separate from that observation. You are the act of it taking place. Modern cosmology hints that even the death of the universe may not mark an end. Whether space continues expanding indefinitely or collapses in a distant future, information conservation implies that the total record of existence remains encoded within the structure of space-time. Some theories of quantum gravity even propose that new universes can emerge from the remnants of old ones, like branches sprouting from an endless tree. In this framework, being is not confined to a single cosmos, but is the property of the total reality that includes all possible universes. Infinity, once again, is quiet, not because nothing happens, but because everything that can happen always does. Awareness of this vast continuity can feel overwhelming, yet it can also be profoundly calming. It means that nothing stands outside existence, that every loss is only transformation, and that every moment, however small, participates in the unfolding of eternity. The sense of separation that defines ordinary life softens when viewed through the lens of physics. You are not a fragile entity navigating a hostile void. You are the void itself, momentarily arranged into consciousness. The stillness you sometimes feel when the world grows quiet is not emptiness. It is the perception of that underlying unity. In the end, the quiet infinity of being is not a mystery to be solved, but a reality to be experienced. It is the silence beneath motion, the continuity beneath change. Science reveals that the universe conserves everything, remembers everything, and evolves without pause. Every version of you, every thought, every world that has branched from the whole remains part of this unbroken continuum. The same physical laws that govern the birth of stars also sustain the spark of awareness that wonders about them. And as your own awareness drifts toward rest, you can feel this continuity gently. The breath you exhale mixes with the atmosphere. The warmth of your body radiates outward. The neural activity of your final waking thoughts dissolves into the calm rhythm of sleep. Nothing you are is lost. It simply becomes something else. The universe, infinite and quiet, carries every trace forward. Perhaps this is the deepest form of peace, to know that being itself never ends. Beyond beginnings and endings, beyond light and decay, there is only the seamless continuity of existence. You have always been part of it, and you always will be. In the stillness between thoughts, you can almost feel it, the soft hum of reality persisting, infinite and calm, forever becoming itself. You made it to the end, my friend. Another journey through the strange beauty of existence. If you're still awake, there's another story waiting for you. One more quiet path through the universe to dream along with. But if your eyes are closing, sleep well among the stars. The cosmos will keep watch.